Problem 38. Mark elements on array by performing queries. The description looks a bit complex, but I just go through some important points. So first, it's like you are given an array of queries, and each query has two things. One is called index, one is called k. So the index will mark the element as the index I. So if it's not already marked, and the k means we should pick up at most k minimum elements from all other unmarked elements. So and each query we should get the answer. We should get the answer, and the answer is the sum of all unmarked elements in the array. So so here we just need to go check this example first and see how it really works. So for this query, the query 1, it means this query 1, it means it will mark the index 1. So in the first run, this element 2 should be marked, and then we need to pick up two minimum elements by the two minimum elements, and if they have the same value, should pick up the index, the lower index one. So it's like this one we can see the 2 is already marked, and the minimum element is 1, and we have 3 over 1s, but we only need to pick 2 of them. It's like we marked this one and then this one, just like how they draw the underline here. And then the result is the sum of all other left elements. And this is the questions. And in our case, because every time we will need to get the sum of all the unmarked elements. So there's some optimization. We don't need to keep the sum, recalculate the sum every time. So we can just get the sum first, and every time when we mark the elements, we should minus the marked value. So here, this is what we can do, and then for the because every time we need to pick up so for the first part of the query to mark by the index is easy, and we can have a site to record which index can be marked. So let's see, create a mark set. And every time for the query, just get this construct as the index and the k in queries. And if the mark, if index not in mark, so mark at index, and we also need to remove that from the sum events. And I will create a result array to put our result. So I assume at the end I need to append this result to the sum to our result, and we should retain it. This is the first part to mark by the index, but the second part is that we need to find the k unmarked the minimum unmarked elements in the array. So Here are several ways. So I will show two ways. One way I have ever used is to sort it, and when we sort the result, I think we need to check the original index. Otherwise, because once we marked it, we need to add the index to the site, and the other is about the original value. And based on this value, we can just sort by these two things, and then we can get a sorted array. So just do this with index equals, I will use Python on it. So sorted, I will just sort it directly, and should be the value and also the index. So if index value is smaller, it will be put in front, and the index smaller, it will, if they have the same value, they will sort by the index. So for index and the enum in evaluate enums, this is what we need, and here we can handle k, because we need to check the k. So but every time, so if k larger than 0, and they also mentioned if less than k unmarked elements exist, then mark all of them. So we don't know how many elements is left, but we cannot just remove the marked things from this. So we need another way to check it. So I will create an index called I, and this I is the index of this array. So we start with 0, and then assume when the I reach out the end of this array, it means we don't have any more elements to do. So in that case, we need to exit the for loop. So so we need to know whether current, so the current elements is this, and then we have the NUM and the index. So if index not in mark, we should do something. We will need to add it to index, do the same thing like this, and then we should I think this is not used, and then after edit, we need to move our index. So the k should be -1, and we need to move the index I. So if index already exists, we still need to move I, otherwise we will fall in for endless loop. So after that, we should be good, I think. Should be fine. We just run it. Okay, looks good. Okay, that's one way, and I also want to show the other way. So here, because we just use the sorted, and I checked the topic, it has other solutions like the heap. I will just try with heap. So if we are using heap, we need to use Python's heap queue, and just heap heap equals should be this. I will use this, so it should be the same, like our sorted. And then heap, just heapify it. And we don't need this. The first part mark the index still be the same, but we don't need the index I to check the move of our elements, and then this should be replaced by the heap when the heap is already still has things, and the index is getting from the heap as well. We don't need to check these anymore. And let's see, we can replace this no, and looks good. Yeah, and this is a heap solution. That's it. Thank you.